Think of your body as a massive city where over 30 trillion incredibly demanding residents live. These residents, yourselves, need a constant supply of oxygen to survive, and they produce a lot of waste that must be cleared out immediately. To handle all those deliveries and pickups, your body relies on a dense, sprawling physical highway system made of blood vessels. But a highway system needs a way to keep traffic moving. The central dispatch engine, driving billions of delivery trucks forward every single second, is your heart. This animated logic model shows how it actually works. While it looks like one big muscle, it is actually a duplex. It operates as two completely separate pumps glued together side by side, split right down the middle. When you view the heart as a dual routing logistics hub, the way your body manages 30 trillion simultaneous deliveries begins to make sense. When your blood finishes a long trip around your body, the trucks are empty and exhausted. This depleted blood arrives exclusively at the right side of your heart. This right side pump has one specific, relatively gentle job. It pushes this empty blood next door to your lungs. This flow diagram tracks the exchange. Blood drops off carbon dioxide waste so you can breathe it out, then immediately loads up with fresh oxygen. Once fully loaded, it leaves the lungs and heads right back to the central hub. Without this continuous short-distance warehouse run managed by the right side, the entire highway system would just be circulating empty trucks. Now fully loaded with oxygen, the blood returns to the heart, but this time it enters the left side. The left pump handles the global delivery. It blasts this fresh fuel out to every distant corner, from the top of your brain to the tips of your toes. Pushing fluid that far takes an enormous amount of pressure. Because of this, the left side of the heart is built with significantly thicker, more muscular walls than the right side. That physical imbalance between the two sides exists because of the scale of their routes. One side nudges blood to a neighbor, while the other powers a whole body network. With so much fluid moving at high pressures in two different directions, the heart must prevent backward flow, or massive traffic jams. The internal architecture solves this. Each side has two levels, an upper collecting room and a lower pumping room. One-way valves separate them. They open downward, letting blood fall. When the bottom rooms squeeze, upward pressure instantly snaps the valve shut, preventing backward flow. When those sturdy biological doors slam together against the pressure of the blood, they make a distinct physical noise. The famous lub-dub sound of a heartbeat is the acoustic signature of those traffic control doors slamming shut to keep the blood moving forward. Despite different destinations and pressures, both sides squeeze at the exact same time. They're locked together in perfectly coordinated rhythm. This dual pump fires 100,000 times a day. It maintains that rhythm without a single moment of rest for your entire life. If you press your fingers to your wrist or the side of your neck, you can feel that rhythm for yourself. Feeling a pulse is a direct connection to this delivery network in action, a synchronized double pump keeping 30 trillion cells thriving.